We're going to look at some non-rigid transformations. So non-rigid transformations is when the shape of the graph is actually changing. Remember, before we kept the same shape of the graph, it just moved around. Now our graph is going to change, skinnier, fatter, some of those things. So we're going to start over at Desmos, and we're going to look at the function y equals the square root of x. And I've already graphed that here. So my first question is, what if we multiply it on the outside by something? So right here, 3 times the square root of x. And you can see this in the blue. It's kind of widened out, stretched in the vertical direction. You can see there. Now, what happens if we use something else? Now, if we use a bigger number like 9, it's just going to stretch even further. But what if we use a smaller number, particularly a number in between 0 and 1? So that's the next one I want to look at is y equals 0.5 times the square root of x. And you'll notice this kind of flattens it down. You can see that green graph there. So we call that a shrink in the vertical direction. It's kind of smashing it down. Okay, so I'm going to take those off so we can explore a little bit more. So again, here's our parent function of y equals the square root of x. Now I want to see what happens when I put those numbers under the square root. So instead of doing 3 times the square root of x, what happens if we do the square root of 3x? And you can see here, this is also stretching a little bit, but honestly, it looks a lot like the first one. But we call this a horizontal shrink. So if you can think of it kind of smashing together in the horizontal direction, I'm going to admit it looks very much like the y equals 3 root x. I can put that one back up here. But the textbook calls this second one, the square root of 3x, as a horizontal shrink. So if you think about from the horizontal direction, kind of smashing it down together. Okay, so then what happens if we put the 0.5 on the inside, something smaller than 1? And again, you can see that we have stretched it out a little bit in the horizontal direction, or you can think of smashing it down in the vertical direction. So again, it's very similar to having the 0.5 on the outside, although slightly different. Okay, it takes a little bit different shape there. So let's try and summarize these things back on our notes. So if we take our function and we multiply it by c on the outside, where c is greater than 1, this gives us a vertical stretch. Okay, so you grab the graph and you kind of stretch it in the vertical direction. If we put c, f of x, and c is between 0 and 1, so some fraction or decimal, that is a vertical shrink. So imagine in the vertical direction just kind of smashing it down, top and bottom, smashing it down. Now, if we put the c on the inside of a function, so f of cx, and again, if c is greater than 1, we call this a horizontal shrink. So from the horizontal, kind of smashing it together. And then if we put f of cx, where c is in between 0 and 1, we call that a horizontal stretch. Okay. Now, you'll notice when you graph these that these two look a lot alike. Stretching something vertically and shrinking something horizontally, that's essentially the same thing. And then also these two are going to look a lot alike. So shrinking something in the vertical direction, stretching in the horizontal, those look a lot alike. There's some technical differences in there, so I do want you to learn the difference, but in practicality, when you look at the graph, they're going to seem very similar.